let's get into some basic concepts about vector, definition of vector and types of vectors, everything one by one. Okay, so see, if you take take a line in a space, so space, I'm not talking about two-dimensional anymore. Space is three-dimensional place, right? So in a given figure, there is I. I is a straight line in three-dimensional space. There is a straight line like this, okay, with an arrow that is indicating the direction of the line. Okay, so there are different directions. There is a direction upward here in the figure 1. In the figure 2, it is downward. In the figure 3, we are having a segment, which is, I mean, the entire line is uh, cut into a segment starting from A to B and in the direction like this. Okay, so here a line with any direction is prescribed as called as a directed line. Example, first 1 and 2. One is a directed line upward and this is a directed line downward. Whereas in the figure 3, directed line is restricted to a line segment AB and has a particular magnitude. The length of this line segment is the magnitude of this directed line. Okay, and it is also having a direction. So that directed line segment has a direction as well as a magnitude. Okay, so that's where we are giving a definition now. Definition of a vector says a vector is a quantity having both a magnitude and direction. In this particular example, this magnitude starting from A to B in the direction of A to B is represented by AB above that arrow mark from where it is starting from A to B. Suppose if it's starting from B to A, I would have written B, A and arrow mark above that. We can also name this as a small letter A. It depends upon how you are naming it. Okay. The point A where the vector starts is called initial point. Okay. So A is the initial point, whereas B is the final point or terminal point of the terminal of the vector. Okay. Now, what is this position vector? So, what is a position vector? Suppose if you want to represent a point in a space, it is very easy to, let me write down. A space means we have three-dimensional axis, three-dimensional directions, right? Just a second. Yes. So I am defining three dimensions along the three-dim axis, which is X, Y, and Z axis. Please, I am rewriting the same diagram here. So please pay attention. So it's very interesting, the different aspects of vectors. Okay, so there is a point P here, and O is the origin of this X, Y, Z axis, or a three-dimensional space represented by X, Y, Z axis. Okay, so I'm joining this in the space. Okay, so yes, let me write it even better. There is a reason why am I carefully writing this to show all this. Yes, this is point P. Okay, so now I'm going to join this O to P, and this is a line segment now, right? So if I don't do anything, it just remains as a line segment. Now I'm going to give a direction for this. So OP becomes a vector, and the length of this vector, let it be represented by R. Okay, so what is the coordinates, three-dimensional coordinates of this PB, X, Y, Z? Now, this OP becomes a position vector. Let P be a point on a space having the coordinates x, y, z with respect to the origin 0, 0, 0. Then OP is a vector having O, that is origin, and P as the initial and the final terminal points respectively. That means any vector which starts from the origin to a point, we can call it as a position vector. The main reason why it is called position vector is it represents the position of the point in the space. Okay. So, and what is a magnitude? So we know a vector has both direction as well as magnitude, right? The direction is from O to P, we know. And how to find the magnitude? The magnitude is, suppose if I am writing a perpendicular from this point, okay, from this point, yeah. So if I am writing a line, a perpendicular line from the point to all the three axes, this is making 90 degree. okay, with respect to x-axis, and the same thing is making 90 degree with respect to, so assume y-axis, and let the same thing make a 90 degree with the z-axis. Okay, then when you draw the line perpendicular, so there will be a projection of that point on the x-axis, which is equal to say x value because its coordinate is x, and similarly its projection along the y-axis will be, the length will be equal to small letter y, and the projection of the same with respect to z-axis will be small letter z. Then how to find the magnitude of this is, suppose you take a three-dimensional cube, okay, of the dimension x, y, as well as z height, then what is the diagonal length from this point to this corner? That is actually square root of x square plus y square plus z square. That is length square plus what is it? Height square and breadth square. It is coming from simple Pythagoras theorem. Same way, the magnitude of this vector, we can represent the magnitude of the vector by taking the square root of sum of the squares of its projection along three axes. Okay. Suppose if the vector P lies on x-axis alone, it is not on the space now. It is lying on the x-axis, xy plane. Let us assume xy plane. If it is on the xy plane, what happens is the distance along the z-axis will be 0. Then it will be simply become what? X square plus y square. Similarly, if it is on the YOZ plane, if it is on the YOZ plane, we will not have x coordinate. Then it will be simply square root of what? Y square plus z square. So can you imagine what I'm saying? Suppose if it is on the XOZ plane, it will be only x square plus z square. It won't have y value. Suppose if it is in the origin, all x is equal to 0, y is equal to 0, and z is equal to 0. Then the magnitude of that particular vector is 0. It is also called zero vector. We're going to see this in the classification of vector. For now, try to understand representation of a vector. The magnitude of the position vector is given by square root of its projection along x-axis, y-axis, and z-axis. Okay, so that is very easy to understand. If you imagine this as a cuboid, okay, and if you're just finding the three-dimensional diagonal length of a cuboid, that is what it is. Okay, we can easily correlate with that. Let's go to the next part. Okay, so when we represent vector, there are different aspects we need to understand. So just like I showed you here, there is a point here. I hope you can see this picture clearly. Let me zoom it. So there is a point whose coordinates are given as x, y, z, and I'm drawing a line parallel to x-axis and perpendicular to x-axis, parallel to z-axis here. And this quantity is x. And along the x-axis, along the y-axis, we are taking it as y. Along the z-axis, we are taking it as z. Right? So now the angle the vector makes with respect to y-axis in this direction is called beta. The angle the same vector makes with the x-axis at the origin, not in this perpendicular line. Perpendicular is always 90 degree, right? From the origin, with respect to origin, that can be alpha with x-axis, beta with y-axis, and gamma with z-axis. Okay, so just try to understand. Assume that line OP in a three-dimensional space passes through the origin. The line forms a positive angles. Positive means we always go for the anti-clockwise direction. Okay, positive angles with respect to x, y, and z axis respectively. These angles are called direction angles. Remember these words of the line or the associated vector. Cosines of these angles, that is cos alpha, cos beta, and cos gamma. These are called direction cosines, and each of them respectively are represented by letter L, M, and N. Okay, L, M, and N. Okay, so the good thing about this is, what is L here? L here is cos alpha, that is x by r. R is the length of the direction of the vector, only magnitude of the vector, whereas x is its projection along x-axis. Similarly, what is M? M is cos beta, which is equal to y by r. And what is cos gamma, which is represented by N? Okay, that is z by r. One good thing is if you square them and add them, what we get? When we square them and add them, we get x square plus y square plus z square divided by r square. We know x square plus y square plus z square is nothing but magnitude of the given vector, which is r square by r square, which is equal to 1. That means the sum of the squares of the direction cosines is always equal to 1. Remember this. If any one thing is missing, we can find out using this formula. Okay, and let me erase this now. Along with that, we know L is equal to x by r. Then what is x? It's called LR. Similarly, y is MR and z is NR. So we can also give a letter like A, B, and C instead of writing x, y, z. That direct particular length can be taken as C along y-axis and A along x-axis and B along y-axis. Then which can be written like this, and these are called directions ratios. Direction ratios. Okay, remember this. These LR, MR, and NR are proportional to the direction of cosines, and they are called direction ratios, are represented by A, B, and C. Okay, so remember this, and remember A square plus B square plus C square is not equal to 1. It is only the cosine sum square is equal to 1. That's very important thing to remember. Okay, so is it all making sense to you right now? Yes. Okay, so let's move on to the next part of vector.